Okay. All right. So, James' arm is beautiful, but let's continue with the geometry we came here for. Unless you want to come up and do show and tell about your arm. How long have you had it? Got it when you were just a little baby? Wow. Okay. So now let's do our first congruence theorem. The congruence theorem you're all familiar with. The side angle side congruence theorem for triangles. Now we know what it means for two triangles to be congruent.
Yes.
All right. Erase all that. Nice to have an eraser. Where's my pink? There's my pink.
Wow, that's so cool.
All right, so this is theorem 6.4. Theorem 6.4. That's a 4, not a 9. So what does it say? It says if AB is congruent to A prime B prime, angle A is congruent to angle A prime, and AC is congruent to A prime C prime, then triangle ABC is congruent to triangle A prime, that's an A prime, B prime, C prime. Alright, so let's get our picture real quick so that we can see what we're talking about. So we're going to start with two triangles. Maybe draw them so that we can, it's obvious from the picture which side we're referencing.
Yeah.
So we've got two triangles. We'll go A, B, C, A prime, B prime, C prime. So we've got these two triangles, and we've gotten, we construct them such that this is congruent to this, that's congruent to that, and that is congruent to that.
Yep.
Good? So now we need to prove that that means that these two triangles are congruent. Okay? And we know how to use side angle side right out the door to give us that. Maybe use blue for what we're going to add. So side angle side right out the door is going to give us this is congruent to this, right?
Yep.
And this is congruent to this. So the crux of the proof is showing that this side is the same long as that side. And once you show that, you've shown that these two things are equal. Okay? So here's big picture how we're going to do that. We're going to pick a point here, call it D prime, on there, and we're going to construct it so that this is congruent to this. Okay? So I'm going to construct it so that that segment is the same long as that segment, and basically prove that D prime has to be the same point as B prime.
Okay.
Do you see what I'm saying?
Yeah. So you're kind of going to do it by way of contradiction.
Yeah, I'm going to do it by way of contradiction. I'm going to say, draw this point on here like that. I'm going to construct this angle right there. I'm going to use side angle side again to show that this angle is congruent to this angle. So that I have this angle is congruent to this angle is congruent to this angle. And then by my existence postulate, right at the beginning, we said, remember when we talked about an angle? If I've got some angle A up here, and I've got A prime down here on a line, then there is only one ray I can draw up here so that this angle is congruent to this angle. There's only one ray I can draw right there so that that's congruent. So there is only one ray I can draw from A on this side of this line so that this angle is congruent to this. I can't have this angle and this angle both congruent to that unless they're the same angle. Okay? That's going to be where this proof gets kind of confusing. Then once you see that, you'll see that D prime is on this ray, D prime is on this ray, the two rays intersect. Two rays only intersect at one point. They intersect at B prime, and they also intersect at D prime, therefore B prime and D prime are the same point. So it's not a proof by contradiction. We're just going to show that D prime is B prime. Okay?
Yeah.
So that's,
But you're doing it by saying that D prime can't be in this, cannot be B prime.
So it is kind of a contradiction, is what she's saying.
well, I'm going to say just pick D prime so it's this far away from C prime. And then it happened to land on B prime is what I'm going to prove.
Okay.
Does that make sense?
Yeah.
So I'm just not going to draw on D prime so that we don't assume things we can't assume. Alright, so that's big picture what I'm doing. And if I kind of lost you in that, we'll recover it step by step. Just wanted to walk you through big picture and then restart. Okay. So 1. Maybe erase the picture too and restart and draw the picture as I go. That'd probably help.
Yes.
Okay. So reset up our picture. Maybe I'll do the words in the picture. 1. Let triangle ABC and triangle A prime, B prime, C prime exist such that AB is congruent to A prime, B prime. Angle A is congruent to angle A prime. And AC is congruent to A prime, C prime. Right? Okay, so now let's draw our picture for what we're talking about so far. So I'm saying we've got triangle A, B, C, and we've got triangle A prime, B prime, C prime. And we know that this side's congruent to this side. We know that this side is congruent to this side, and that this angle is congruent to this angle. That's what we have so far, right?
Yes.
Okay. So now we're going to use side angle side to show that these two angles are congruent to these two angles.
Okay.
So 2. By side angle side postulate, maybe to specify we're not talking about the actual proof we're doing, because this is called the side angle side congruence. This is the congruence we're doing. So by the side angle side postulate, maybe I'll say since AB is congruent to A prime B prime, angle A is congruent to angle A prime, comma, and AC is congruent to A prime C prime, comma, then we know angle B is congruent to angle B prime, and angle C is congruent to angle C prime. So let's write what that added to our picture. So pink's what we started with, blue's what we're adding. So we're adding to our picture, that is congruent to that, and that is congruent to that. With me so far?
Yep.
I don't know why I keep putting my little ring right there. Okay, so now I'm going to construct my point D prime such that C prime D prime is congruent to BC. So 3. Let D prime on line C prime B prime such that C prime D prime is congruent to BC. So my D prime could in reality be past B, my D prime could be over here, my D prime could be right on B prime. It could be anywhere on that line. I'm just arbitrarily drawing it right here. Good?
Yes.
And so now we know that this is congruent to this. That's how we constructed it. Still with me?
Yeah.
Okay. So the next part is words then picture. Words then picture. So 4.
Are they rated equal?
Since D prime C prime, I'm going to use side angle side again with side angle side, side angle side to show that maybe it helps to show which triangle I'm going to use. I'm going to draw that triangle basically. So I'm going to use side, angle, side to show that this angle is congruent to this angle. Okay? Since DC is congruent to BC, angle C is congruent to, or C prime is congruent to angle C, and A prime C prime is congruent to AC, then angle C prime A prime D prime is congruent to angle A. You see that? That's the whole hard part of the proof. So we just basically said that angle is also congruent to that angle.
Yes.
Good? Now, our postulate, our existence postulate of angles, tells us that there is only one angle on this side of the line such that that angle is congruent to that. I can't have this angle and this angle both congruent to that and not be the same angle, right?
Right.
So 5 postulate 5-1 angle C prime A prime D prime congruent to angle A congruent to angle A prime implies angle C prime A prime D prime is congruent to angle, not even congruent, they are the same angle since they're on the same side of the line, is equal to angle A prime. You follow that logic?
Yeah.
Maybe we could have been a little bit more verbose about arguing how both these angles, how D prime and B are on the same side of this line and C prime. But we're at the point where we're going to kind of just rely on our pictures to talk about things now. Okay? Alright. So, what does that mean? That means that D prime is on A prime B prime. It's on that line. It has to be on the ray that comes out from here. In other words, this ray and this ray are the same ray.
All supposed to be on
In other words, D prime is the same.
So in other
as
words,
B prime. Therefore.
then ray A prime B prime is equal to, is the same array as A prime D prime. So 7, since D prime is on
B prime.
A prime B prime and
It's on A.
C prime B prime, it is the point
B prime.
where the
Rays
lines
intersect,
or rays intersect,
which is point B prime.
comma, namely
Point
B prime.
Therefore. BC.
8, therefore,
B prime.
A, B, C.
B prime C prime is congruent to BC, and so triangle,
ABC.
geez, that is really disappearing.
Yep.
Triangle ABC is congruent to triangle A prime, B prime, C prime.
Yeah.
Did you follow all that?
Yeah.
It gets a little bit messy for the first one, but the congruence proofs after this I think are easier. Okay. So we finally have a way about talking about congruent triangles. And we now have a way that we can prove two triangles are congruent. So let's arbitrarily open our, not arbitrarily, let's open our book to a random problem in whatever section comes after this here. And what theorem did I just do? 6-4?
4.
Anyone know what page we're on?
It's 94.
94? I haven't been using my book, so. 94. Okay, so pick some exercise out of 6-8 and let's see this in action.
2.
You like 2? Okay, we'll do 2. And maybe we'll just draw pictures and talk about the pictures. We won't write out the full proof. I think it's enough to just do that so you can see how it goes. Rather than me holding this and having you guys tell me that, we just flat out tell me. So what we doing? Tell me what the picture is.
It's a parallelogram
So we've got some parallelogram
with a line drawn slantway through it.
with some line like that.
Yeah.
Give me points.
That's
E.
E, F, H, G. The top angle right there.
The
No,
line
other
is
one
1.
is 1. Bottom one is 2.
Okay?
Yep.
And what's given?
Given the figure that
Angle
ace-
1 is
oh,
congruent to angle 2.
yeah.
And EF is congruent to GH. And we're proving that triangle EGH is congruent to triangle EFH.
Sorry. So we're proving that two triangles are congruent,
Yeah.
right? So we're proving triangle and order matters, so we'll say
EGH.
EGH.
EGH is the way they do it.
Yeah.
So EGH is congruent to
HFE.
HFE is the way it has to go. Triangle HFE. That's a congruent symbol.
Well,
Okay, so let's see. So we know that, who cares about these 1s and these 2s? We'll get rid of them. We know that angle is congruent to that angle. And we know that that side, EF, right there is congruent to that. That's what's given.
and you know that
EH is congruent to
EH is
itself.
congruent to AG.
Yeah, and this line is congruent to itself.
There you go.
Now you have
So we've got,
side angle side.
looking at this triangle and this triangle, we have this side is congruent, this side of this triangle is congruent to this side of this triangle. We've got this angle on this triangle is congruent to this angle on this triangle. And we've got this side of this triangle is congruent to this side of this triangle.
Therefore, they're
So
all
if they have a
base
side,
angles.
an angle, and a side in common, the two triangles are congruent.
Yes.
You see that?
Yeah.
So,
All done.
do we need any explanation on there? Should we write it out? We need explanation? Alright, let's give explanation. So, 1, observe, the only added fact we needed is that EH is congruent to EH. Then, since EH is congruent to EH, angle, maybe put those back so we can talk about them easily, 1 and 2. Angle 1 is congruent to angle 2, comma, and and EF
Since EF is congruent to GH.
is congruent to GH, comma.
And then
You might be right. Did I write it backwards? EF is congruent to HG. Thank you. EF is congruent to HG. Then triangle EHG EHG is congruent to triangle.
H-E-O.
Oh,
Yeah,
our
H,
EH should have been switched here, right?
No, it doesn't.
So let's see. On one triangle, we want to talk about FEH. Is that the way that they do it? Maybe we'll just use what they do. No, they do it dumb. Go towards the angle you're using. I don't care about theirs. Go from side to the angle to the side. Go from the side to the angle to the side. That's the way I like to think about it. I think it's more useful that way. So,
Go to F-E-H.
so HE, which triangle do we do first? The one with the 1. So HE is congruent to EH. Angle 1 is congruent to angle 2. And EF is congruent to HG. So, triangle
H-E-F.
HEF is congruent to EHG. Triangle, thank you. Yeah. Little triangle. Okay.
Are you saying that's the whole proof?
Yeah.
And where did we use theorem 6.4?
The
Is
side
that
by
SA?
side. By side.
Then that is congruent to that by side, angle, side. Now this time we're not talking about the postulate side, angle, side. We're talking about the congruence theorem, side, angle, side.
By side and
I see.
Okay? So now are we good?
Mm-hmm.
Alright. Is there another homework? Come on, find a real messy one.
There's no messy
Pick the
one.
hardest one you can. Is there any with the star next to it?
barn.
Barn? Alright.
Barn.
Let's talk about a barn.
Barn.
Give it to me.
A farmer.
Maybe just
Wishing
let me see
to
real
find
quick.
the distance.
ABCDE. So we've got picture something like that. He calls that A, B, C, D, E. And I guess he does like a dotted line here and he says, here's the barn.
In the center of it, there's a box that says barn.
There's a barn right there.
Yeah, a literal barn.
Ah, he draws. Boom, we got a barn. There it is.
Listen, Barnaby.
Okay? So a farmer is wishing to find the distance between posts at A and posts at B. He places a stake at C, and on the lines through B and C, places a stake at D. So basically, BC, the length of BC is equal to
The length of B.
the length of CD. So in other words, that segment is congruent to that segment, right? And what else do we have?
AC
Then
is
on the
congruent.
line-
AC is congruent to CE.
Well, then there is congruent. It says is.
Well, it says the length is equal, but we have a theorem from chapter 5 that says AB equal to CD is logically equivalent to AB is congruent to CD.
Why do you not do the segment things when you're doing? Okay.
You're saying draw the line above it?
Yeah.
Okay, so I don't know if in your geometry textbook that you did in ABCDE, if they use this to mark, we're talking about a segment. Other textbooks don't do that. This means a number. When you put a line above it, you're saying the length of. The length of AB. You infer from context whether or not we're talking about a segment versus a line. But when there's a line above it like that, we mean the length of. This is a number. This is not a segment. This is a number. This is 7 or 5 or whatever. It's not a geometric object. This is a geometric object. This is a line segment.
Okay.
So this is a set of points. This is a number. Does that make sense? Okay. So, what were we trying to prove?
You're trying to prove that
I guess we're trying to prove that this distance is equal to this distance.
he measures DE and finds the length is 78 feet.
Okay.
So we're basically trying to prove that two triangles are congruent. So we can find
So-
DE is congruent to AB.
We're basically trying to show that whatever that is, forget the
We're
line.
trying to prove.
We're trying to show that that is congruent to that.
Yes.
DE is congruent.
Those are the same distance.
Which would be easy.
Yeah, and you can already see it. Oh, you got vertical angles. Look at that. Side, angle, side, side, angle, side.
Two triangles are congruent.
Two triangles are congruent. I said give me a hard one.
There are no hard ones.
Oh, so you guys are just going to cruise right through that homework.
Number 10.
It's going to be a breeze. Too
Why
late.
don't we just look at them and
Too late.
Yeah, we're moving forward now.
Okay.
Phew,
You might be right.
can't turn back
Now,
now.
AD.
You had your one chance. Well, maybe it's getting a little late.
Yes, we should just do on.
So,
It's getting late. Maybe we should just do the homework.
Yeah.
yeah, maybe we'll just keep going on homework problems, and because I want to leave enough of chapter 6. We're not going to finish the rest of chapter 6 today, so I want to leave enough of chapter 6 for it to be chapter 6 next class. So next class we'll finish chapter 6. So from here on out, we'll just do whatever random problems you guys want.
Okay, 10 through 10.
Well, that's homework.
10
Homework?
through 5.
Every problem in chapter 6.
Every problem in the chapter.
That we've gone through so far. Do it all. I'm dead serious. You don't need to write out full proofs if you don't want. Just do the pictures like we've been talking about. But they're quick. They're going to give you concepts that are going to be useful to you.
Can we just do what you've done? Like, so you take the color and you say what we already have and then say what you find to find the answer?
Coloring pencils.
Yeah, I just
Sure. But let me tell you this. You writing out these proofs thoroughly would actually be a great exercise for you guys, writing proofs and stating everything.
It's also very painful.
Yeah, your hand gets tired, right? I know.
Even though-
I write out all the definitions and theorems ahead of time, and I pick random homework problems I think are hard, the harder ones, and do them. Because I come to class prepared. You know?
I was fully prepared.
I don't just watch the lecture.
Yeah, maybe his games too.
I double task.
You multi. Oh, she was playing games while watching it.
I was
She
not.
wasn't even.
No, I.
All right, that's fine. Okay, so pick a random problem.
Put it on double speed.
You can do 10.
10.
We can do 10.
10.
I vote
So
we
we've
should
got
have Emma do a problem.
A, B, C, D, E. Oh yeah, let's just have you guys do problems. There we go.
Then go.
Emma.
Nim's already done one. So I'll set it up, and then we'll pick someone to come up and do
Give
it.
Emma the hardest one.
Give Emma. Give Emma a hard one.
I'm not worried about Emma learning the material. I was very worried about him, so
Holy cow. Excuse you.
I'd like to stay actually. But thank you. All right, and then let's see what's known.
That E and C.
In the figure, AD is congruent to EC.
And BE is congruent to
AD is congruent to, what did I say?
BD. EC.
AB. EC.
EC?
is congruent to
BE is congruent to BD.
Did I say that right? Maybe I keep looking at two different pictures. AD is congruent to
EC.
EC. Oh, AD, not BD. So AD, this full segment, that's a bad way to do it. Let's come up with that.
Just do the color you need.
So we've got
A.
that segment is congruent to that segment. How's that?
Okay.
And then what else do we have?
We have it. Triangle A is congruent to
BE is congruent to BD, so BE, okay. So that's what I was going to do before. And we got that is congruent to that, right? All right. Who's going to come up and do it?
James.
James? All right, Debbie.
No, please no. Please, please, please.
Come on. Come on, come on, come on.
Cannot do it.
You can sure try. You got a whole class to walk you through it. And I'll even let you pick any marker you want.
It's tree.
You don't think you can do it? All right, James. Come on.
He's gonna right now too.
Exactly.
Can I do it? She wants
Sure.
to.
All right, Leah.
Okay. Do you want me to write out everything?
Oh, I don't even know what we're trying to prove.
Trying to prove that the
ABC
is isosceles.
Oh. So, in short, we're trying to prove this side's congruent to this side.
Yeah.
Okay.
You want me to write out everything?
Explain to us as we're going, and if we have questions, we'll ask you why.
Okay. So,
Why?
okay, so because this segment is congruent to this segment, then this triangle is an isosceles triangle. That means that this angle is congruent to this angle.
Perfect.
Now, because this segment is congruent to this segment, these two are congruent and these two are congruent, that by side angle side, you make,
Show us the two triangles you're talking about. That will help them see it.
I'm just gonna try. So you have a triangle A, B, D, and you have a triangle B, E, C. So we know that BE is congruent to BD, and we know that AD is congruent to EC, and we know that
Beanie.
BED, BEC, sorry, is congruent to BDA.
So stop for a second. Do you see the two inner triangles that she redrew?
Yeah.
And she recaptured all the information. So that side's right there, that side's right there, that angle's right there, that angle's right there. So you've got that triangle kind of if you cover up that segment, and then you've got that triangle kind of if you cover up that segment, or the two triangles she's drawn here. And that's what she's got so far. Everyone see it?
Yeah.
Awesome.
Then by side angle side, you can say that the two triangles are congruent, therefore making this one congruent to this one. Making this one congruent to this one.
Wonderful.
Sweet.
And making that my isosceles triangle.
Great.
Awesome.
Don't worry, Debbie, I've done this before. Yeah, I have.
And that's one of the beauty of going over all these exercises again. So that's why I was kind of trying to explain at the beginning and said, never mind, we'll see it with homework problems, is when you look at triangles, or when you look at geometric figures, it's so natural when you get comfortable with geometry to start looking at all the triangles you have. Like, how many triangles are actually in this picture?
3.
1.
There's more than 3.
There's like
There's
4.
this triangle. There's this triangle. There's this triangle. There's combining those two. There's combining those two, and there's the whole one.
Yeah.
So there's 6 different triangles in there that you have information to pull out from. So it's a very natural thing to want to do when you're looking at a geometric figure, is to look at all the triangles. And that's why I strongly encourage, it might sound outrageous, but these problems are quick. Even the hard ones are pretty quick once you see it. Just going through all the problems in the chapter, I'm not kidding about that. And it's just going to help you get comfortable doing this. Looking at some picture, identifying all the different triangles and the relationships that you can instantly pull out from those triangles. So yeah, that was great. Right? What's another one?
Let's see.
We can't just let James and Debbie off the hook.
Please.
7. 5.
I'll just understand them. Do that home.
All right, James, you got picked for number 5.
Oh.
What is it?
Let's start with that.
Yeah, I just want the picture. So, A, B, C, D, E. Okay, so they did some logic in labeling points there. A, B, C, D, And then what were my lines connecting with?
B, C,
Those
D.
two are connecting like that. So that's connecting to that. That's connecting to that. And then start telling me what's given.
AB is congruent to AC.
AB is congruent to AC, so
D
that
is the
one.
midpoint of AB.
So maybe we'll do this again. That is congruent to that. Okay, what?
D is the midpoint of AB.
So that little piece is congruent to that little piece.
And E is the midpoint of AC.
And that little piece is congruent to that little piece. And what we're trying to prove?
A angle or triangle ABE is congruent to ACD.
Triangle ABE is congruent to which triangle?
ABE.
ACD.
ACD. So ABE is congruent to ACD. Okay.
Try just drawing the triangles out. It might help you separate the triangles you're going to prove for.
What's the thing with the midpoint?
The midpoint means it divides it into two equal segments.
Okay.
And in fact, because you know that this is congruent to this, and that that's the midpoint of that, basically you can get straight to this
Yes.
information. That's also congruent to that. And maybe we can get rid of these blue lines. That captures all the information. So all four of those line segments are equal. Okay?
So now you know that the triangle A or BAC is isosceles.
BAC is isosceles, sure, that was given.
We can't really say they bisect, right? We can't say that BE bisects ABC, right?
This angle,
Yeah.
no, we can't say it bisects that angle.
Okay.
But exactly what Leah was talking about, drawing out the two triangles that you're trying to prove are congruent is oftentimes very useful. So we're trying to prove that
ABE.
ABE, okay, so yeah, that's what I was going to draw, and maybe try and keep our orientation the same so that we see it. We're trying to show ABE is congruent with
DA.
Oh, I see it
ACD.
now. I'm seeing it.
ACD. ACD.
I'll show what's congruent.
Okay, yeah, I see it.
So what do we know about these two triangles?
You know that A.
We know that AC is congruent to AB.
How do we know that?
It's given.
Yeah, it's given.
It's given. That's an isosceles triangle. AB is congruent to AC, so that side's congruent to that side.
And
Okay.
then we know AE is congruent to DE.
AE is congruent
Or
to
sorry, DA.
AD. How do we know that?
Because of the midpoint.
That's just pulling it right out of our picture. That's congruent to that.
And because triangle BAC is isosceles, then we know angle A is congruent to angle A.
We know that, period. It's the same angle.
Because it's
Has nothing to do with it.
Okay.
It's the same angle. An angle's congruent to itself. It's reflection.
Using side angle side theorem, then
Sorry,
we
I
know
should
that
have
the
done
triangles
2 6.
are
Oops.
congruent.
Congruent. Yeah. So that's the way that these proofs work over and over again. The things you're trying to prove are congruent, find your two congruent triangles, and then you use that to give you more information. You see that? You feel like you can do it now?
Yep.
Identify the two congruent triangles. We'll walk you through it, one step at a time. Remember, you're just looking for congruent triangles. You don't have to come up here. You'll just tell me. We'll see if you can identify it in the picture.
Which one?
You don't think you'll be able to? Okay, we'll try some other ones. We'll pick on someone else. All right. Let's see.
Just do like 4 or something. 4 looks pretty easy.
4? Given that figure, prove that ABC is congruent to that. So, let's see how they label it. Well, that's fine. We can still go through 4. A, B, C, D. A, B, D, and C somewhere in the middle. C. Okay? And what's given to us?
You labeled that one.
AC is congruent to AD.
AC is congruent to AD.
B's in the middle.
Did I draw it right?
No,
Thank you.
Leah is looking at the diagram above.
Oh, I'm looking the wrong way.
Yeah, they keep changing how they label points. It's driving me crazy.
Yeah.
So, are you want
That's
to be
weird.
free?
Okay, yeah.
Okay.
Number 4. Just tell me the information on number 4.
Okay, AB is congruent to AD, and BC is congruent to CD.
What?
Yep, I think I have more information I'm supposed to have. Let's
Yeah.
restart. Tell me what's congruent to what.
AB is congruent to AD,
So that's congruent to that,
and BC is congruent to CD.
and that's congruent to that.
And you're proving that triangle ABC is congruent to triangle ABC.
So we're proving this half is congruent to this half.
Yeah.
Right? So right out the door, we're looking for 2 equilateral triangles. Not equilateral. 2 congruent triangles.
Yeah.
Now, we know that the big triangle is
Isosceles.
isosceles, which gives us this angle is congruent to this angle.
Yeah.
So now we have side, angle, side, side, angle, side. The 2 triangles are congruent.
Right off the bat.
Yeah. Right.
All right, let's draw another one.
7.
7. A, B, E is one of them. So, well, maybe I'll just draw the picture, the big picture first.
Patrick's
It's gonna be
kites.
like 6.
Something like that.
Patrick,
Why?
when Patrick grows big and he has the tights.
Okay. Read the points to me as I go around. So this point,
A,
this point,
D,
this point,
B,
this point,
E,
B with
C?
E. No,
E?
that was E, yeah. And then this one, C.
C. Okay, and what do we know?
That AB is congruent to BC.
So AB, this whole side,
It's just like.
I'm going to do a circle when we're talking about the whole side. How's that? That side's congruent to that side. I'll use a circle when we're talking about the whole thing.
Then you have the same midpoints. D and E are midpoints.
So you know.
Oh, they're midpoints?
Yes.
So I know that that's congruent to that's congruent to that's congruent to that.
Right.
Okay?
And then you're proving that AE is congruent to CD.
That this side is congruent to this side.
Yep.
Okay? Once again, we're just going to prove congruent triangles
And
and then go from there.
Wait, do we know that A, B is congruent to B, C?
yes.
Yeah, that was given.
So you just have to say that B is congruent to itself.
Yeah, the only thing we're missing here is B is congruent to itself. That's congruent to itself. So we've got this triangle, one of Patrick's legs, and we've got this triangle, the other one of Patrick's legs. You see how those 2 triangles are congruent to each other?
Yeah.
Okay, those 2 triangles are congruent to each other, therefore that side and that side of both triangles are congruent. This side and this side are both congruent. Good? Pretty easy?
Yeah.
Pretty straightforward?
Yeah,
Think you can do these?
Yeah.
we already did all of them.
Go through them again. Trust me,
Okay.
trust me, trust me. You of all people should know.
Wait.
8, alright. What is it?
4.
Tell me what to draw.
2 triangles.
2 triangles?
Check half point B.
Like this?
Yeah.
Yep.
So it goes
A.
Start here.
A,
E,
E, B,
B,
C,
Wow, man.
D.
You duped me out, bro.
Alright, and what do we know about?
Yeah,
EB is congruent to BD. And B is the midpoint of AC. And EBC, angle EBC is congruent to angle BAD. EBA.
EBC, so
DBA, yeah.
DBA.
that is congruent to DBA. That.
Oh, that's weird.
You see that?
Oh.
So now we're going to use our equal subtracted from equals or equal theorem, right?
Uh-huh.
Because notice this angle's the same for both those angles.
Yeah, so when you minus that.
So if this whole angle is congruent to this whole angle, and we take away that equal portion from both of them, that gives us that this angle is congruent to this angle. You see that?
Yeah.
Okay.
And then side equals side.
Huh?
How would you word that? Like,
By postulate whatever, since that angle is congruent to that angle, and that angle is congruent to itself, then that angle is congruent to that angle. It's just using one of the postulates directly. Okay? And so now we have side, angle, side. Side, angle, side. Two triangles are congruent.
thanks.
Good?
Yeah.
Okay, so go through, do them. Do all the ones that we did in class for sure, and then some more. Especially if you're not practicing geometry. Tell you, and I'll tell you it again. You'll see proofs done in class. You'll understand it as someone's doing it. When you go to do it yourself, you'll forget. You'll get stuck. That's going to happen. You'll try to remember now, which two triangles did they use to prove that was congruent? Especially like in the picture that Leah had that had 6 triangles in there. You might lose track of which two you were using. So go do them again. Make sure that you understand them. You can turn that off.